Okay, and another important fact is that glioblastoma-derived exosomes have similar properties to their parental cells. What makes them rather safe. So these exosomes can be safely used for carrying the drug. So we can pack the anti-cancer drug into exosomes, and then these exosomes can be distributed within a tumor microenvironment and then kill the cancer cells, and also may inhibit angiogenesis. Okay, but the most important thing that exosomes can easily pass the blood-brain barrier when anti-cancer drug alone without exosomes cannot pass, and it makes them promising candidates for nanocarriers in oncological treatment. Okay, the structure of exosomes can be engineered in a specific way, and that makes a possibility that the drugs can be selectively delivered to the specific cells. So if we pack those drugs into the exosomes and then treat glioblastoma with such engineered exosomes, no, it's okay. It's okay. There is a much better chance for response than by distributing those drugs alone. And as I said before, those glioblastoma-derived exosomes have similar properties to their parental cells, so they might be uniquely capable of communicate with their parental cells and then distribute the drug with each other. Okay, so now some examples from the literature. There were some trials with exosomes in the treatment of glioblastoma. So recent studies indicated that selumetinib is some of the new drugs. It's an inhibitor of mitogen activate protein kinase that inhibits MEK1 and MeAK1 and MeAK2 proteins. So it's all involved in this MAPK pathway. This drug is already used in neurofibromatosis type 1. Those trials included selumetinib that was packed into the exosomes, and such engineered exosomes were used for targeted glioblastoma therapy, because nowadays the standard chemotherapy is slowly being replaced with targeted therapy and immune therapy, of course. And what's the most important fact that such distributed selumetinib does not affect normal cells, so it can selectively target only glioblastoma cells and kill them effectively. Okay, another study was taken up with TMZ and luteolin. TMZ is already, so temozolomid, known as TMZ, is already used in glioblastoma therapy, but as we know, it's not very effective. So in this study, TMZ was packed into the exosomes with a combination of luteolin. Luteolin acts as an inhibitor of NRF2 factor, and it downregulates MGMT, O6 methylguanine methyltransferase. TMZ is an alkylating drug, and luteolin affects MGMT. So one of the most important marker in glioblastoma diagnosis, because if MGMT gene is mutated, then the ability of DNA repairing in glioblastoma cells is limited. So it leads to the better response for treatment. And what's more, luteolin not only acts as an inhibitor of NRF2, but it also uses WNT beta-catein pathway to promote the cell apoptosis. So it limits the DNA repair abilities in cancer cells, and also make them kill themselves in apoptosis process. And another thing is breaking the chemotherapy resistance. As we know that glioblastoma cells are very resistant to chemotherapy. Their resistance level is very high. And another study revealed that the exosomes that are secreted in glioblastoma can regulate TMZ resistance of astrocytes. So the mutated astrocytes gain the resistance and expression of HIF 1A EGFA protein. What makes them more resistant to anti-cancer drugs, mainly TMZ. So it's another point of target. So it's another potential point of target for new anti-cancer drugs that may be. Okay, I'm ending slowly. So. Okay, immunotherapy is also emerging. So there is also a possibility for monoclonal antibodies like bevacizumab, like pembrolizumab, to view impact of the exosomes. And these exosome delivery platforms act as a crux that restores interaction between the proper interaction between cancer cells and patient's immune cells. And it's a key for effective immunotherapy, also in glioblastoma. Okay, so a brief. So now some brief words again about the liquid biopsy. So as I said before, those proteins and other molecules that may be found in the exosomes can be used as diagnostic markers for early detection of glioblastoma. What's more, this liquid biopsy is less strategy than less invasive strategy than the current diagnostic options. And here we have the potential benefits of liquid biopsy. It's a very sensitive and specific diagnostic method. It has a very large potential of early stage cancer diagnosis. So even if the symptoms are not present, we can detect that something is going on, that the cancer is developing. Low invasiveness, because we receive this serum directly from the patient's organism, so it's low invasive. So the invasiveness level is very low, and then we have a panel of specific biomarkers for specific malignant tumor. And we have some examples that in blood and primary brain tumor exosomes, P65, CD117, and DM levels were elevated, while 10 also frequently mutated in glioblastoma, and P53 level was decreased. But in recurrent glioblastoma, DNM and P65 proteins remained increased, but P53 protein was downregulated. So, as I said before, something is elevated, something is decreased, and we can use it in a diagnostic way. Okay, now a brief summary. Glioblastoma is an aggressive type of brain tumor, and it requires urgent therapy. So the new therapies are required urgently for these patients. And many latest discovery reveals the potential of exosomes in efficient diagnostics and treatment of brain glioblastoma. Exosomes can also be used as drug carriers, and exosomes can carry various cargo particles that may be used in glioblastoma, diagnosis and therapy as well. And thank you for your attention.
So, thank you so much.